In this video, you'll learn about the topology of GCP services and how they're distributed geographically in zones, regions, and at a global scale. You'll also learn how you can structure your resources you use hierarchically using organizations, folders, and projects to manage your access control and your billing. Behind the services provided by Google Cloud Platform lay a huge range of GCP resources: physical assets, such as physical servers and hard drives, and virtual resources, such as virtual machines and containers. These resources are managed by Google within its global data centers. Google Cloud provides resources in multi-regions, regions, and zones. It divides the world up into 3 multi-regional areas: the Americas, Europe, and Asia Pacific. Next, the 3 multi-regional areas are divided into regions, which are independent geographic areas on the same continent. Within a region, there's fast network connectivity, generally round-trip network latencies of under a millisecond, and that's at the 95th percentile. Finally, regions are divided into zones, which are deployment areas for GCP resources within a focused geographic area. You can think of a zone as like a data center within a region, although strictly speaking, a zone isn't necessarily a single data center. Now, we mentioned Compute Engine earlier. Compute Engine virtual machine instances reside within a specific zone. If that zone became unavailable, so would your virtual machines and the workloads running in them. And GKE uses Compute Engine, so your GKE workloads could be affected as well. Deploying applications across multiple zones enables fault tolerance and high availability. And in this specialization, we'll learn how to do exactly that. Google's data centers around the world are interconnected by the Google network, which by some publicly available estimates carries as much as 40% of the world's internet traffic every day. This is the largest network of its kind on Earth, and it continues to grow. It's designed to provide the highest possible throughput and the lowest possible latencies for applications, including yours. The network interconnects with the public internet at more than 90 internet exchanges and more than 100 points of presence worldwide. When an internet user sends traffic to a Google resource, Google responds to the user's request from an edge network location that will provide the lowest latency or delay. Google's edge caching network places the content close to users to minimize that latency. Your applications in GCP, including those running in GKE, can take advantage of this edge network too. When you take advantage of GCP services and resources, you get to specify those resources' geographical locations. In many cases, you can also specify whether or not you're doing something at a zonal level, a regional level, or a multi-regional level. Zonal resources operate within a single zone, which means that if the zone becomes unavailable, the resources won't be available either. A simple example would be a Compute Engine virtual machine instance and its persistent disks. GKE has a component called a node, and these are zonal too. Regional resources operate across multiple zones, but within one region. An application using these resources can be redundantly deployed to improve its availability. Later in this specialization, you'll learn how to use GKE so that its resources spread across different zones within a region. Cloud Data Store is an example of another GCP service that can be deployed in a similar, redundant way. Finally, global resources can be managed across multiple regions. These resources can further improve the availability of an application. Some examples of such resources include HTTPS load balancers and VPC, or virtual private cloud networks, which GKE users benefit from too. The GCP resources you use, no matter where they reside, must belong to a project. So what's a project? A project is the base level organizing entity for creating and using resources and services and managing billing, APIs, and permissions. Zones and regions physically organize the GCP resources you use, and projects logically organize them. Projects can be easily created, managed, deleted, or even recovered from accidental deletions. Each project is identified by a unique project ID and project number. You can name your project and apply labels for filtering. These labels are changeable, but that project ID and project number remain fixed. Projects can belong to a folder, which is another grouping mechanism. You should use folders to reflect the hierarchy of your enterprise and apply policies at the right levels within your enterprise. And yes, I know what you're asking. You can nest folders inside of folders if you want. For example, you can have a folder for each department, and with each department's folder, you can have subfolders for each of the teams that make it up. Each team's projects belong to its folder. A single organization owns all the folders beneath it. An organization is the root node of a GCP resource hierarchy. Although you're not required to have an organization to use GCP, organizations are very, very useful. Organizations let you set policies that apply throughout your entire enterprise. Also, having an organization is required for you to use folders. If you're already a G Suite customer, you have an organization already. And if not, you can get one for free through Google Cloud Identity. Your organization will have a fixed organization ID and a changeable display name. The GCP resource hierarchy helps you manage resources across multiple departments and multiple teams within an organization. You can define a hierarchy that creates trust boundaries and resource isolation. For example, should members of your human resources team be able to delete running database servers? And should your engineers be able to delete the database of employees' salaries? Probably not in either case. Cloud Identity and Access Management, also called IAM, lets you fine-tune access controls to all the GCP resources you use. You define IAM policies that control user access to resources. You apply these policies at the level you choose, and those policies inherit downwards. For example, an IAM policy applied at the organizational level will be inherited by a folder, the project, and even the resources beneath it. Additional policies at lower levels of the hierarchy can grant additional permissions. Billing, on the other hand, accumulates at the project level. Most GCP customers have a resource hierarchy that looks like their employee organization chart, while their project billing looks like their cost center structure. The resource hierarchy matters because of GCP's shared security model. When you build an application on your on-premises infrastructure, you're responsible for the entire stack security, from the physical security of the hardware and the premises in which they're housed, through the encryption of the data on disk, the integrity of your network, all the way up to securing the content stored in those applications. But when you move an application to GCP, Google handles many of those lower levels of security, like the physical security of the hardware and its premises, the encryption of data on disk, and the integrity of the physical network. Because of its scale, Google can deliver a higher level of security at these layers than most customers could afford to on their own. The upper layers of the security stack, including the securing of the data, remain your responsibility. Google does provide tools to help you implement the policies you can define at those layers. The resource hierarchy we just explored is one of those tools. Cloud IAM is another. You'll learn more about that security in depth later on in this specialization.